So having a communication there, then having a lot of literature and a lot of databases. So if you're going in and say, well, I have this kind of symptom and so on, so you profile yourself and you ask the system, you know, where do I have to go for? What kind of disease could I have, and things like that. So you start with the rules, and then it will tell you kind of the pattern as an answer. Now we have a colleague here, Edith, and some of you have met her already. She is one of the professors here of this project in Switzerland, and you can talk to her if you have additional questions about that. It's mainly 4 parts we are looking. It's motivation support, it's decision support, social support, and information portal. So like when people get out of the hospital and they maybe had a kind of, let's say, an alcohol problem or a drug problem, they try to support them. And so it should be a very intelligent, interactive platform where when they get back there, they will be hosted a little bit smarter than all these platforms we have so far, where you get bored immediately when you come back the next time. So, you know, there should be much more information and much preciser information for you as a person, as you as a patient, rather than having all this general information where you really, you know already that. And that's not the one you're looking for. It should be more personalized to your needs and motivate you to stay clean and all that stuff. So that's a very interesting project we're doing there. And this is most likely on the semantical level on text and numbers, matching semantic in the sense of text and numbers than images. So as you can see, the technology can serve many different areas. And as I said, we believe that we have founded a new line of evolution. So that means we only scratched on the surface, and we have only experienced, you know, a couple handful of projects and ideas. And what we're really looking for is some joint ventures with universities, scientists, students in exploring that and confirming either that this is what we think it is, or helping us to find the right spot to define what it is, and also to try it on all these different areas. I mean, roboting. When we last time here, we saw the kids, you know, having those robots made where they catch those balls and put it in a basket and then driving around and so on. So immediately I said, well, those are all rule-based systems. Now what happens if we would say we add on to the robot, let's say, pneumatical arms, okay? So he gets four arms. He can lift himself. And let's say we have a square where he is catching those balls. But then we have a one step higher and we have 3 balls on top. And the rules to the computer is catch all the balls. But of course, if he comes to the edge, then he will bump against them because he doesn't go up. Now, instead of having all these pre-made algorithms, we will just teach him how to use his arms so that he understands how he has a concept he can lift him up. But that's all we tell him. And then he has this very strong rule that he has to get all the things, you know, no matter what it needs to. Then he will be able to self-program himself in trying out. It will take hours maybe even days, but he will be enabled to get up there by himself, no pre-program, and find and catch this ball and go back. So this is kind of what this technology enables you to do. So knowing that, it's clear that, you know, this is only a small part of applications we could think about. And I'm sure that our, you know, first tests we did are the most lousy one, and everybody else will do much more famous thing than we will do. Now, there have been, you know, a lot of research on that, and we are not saying that ours is better. Don't misunderstand us. We are saying we found another line of evolution, and I don't even like to judge them against, because every of those lines had her time and was important and was right or wrong, whatever. I don't like to judge that. We just said, okay, we believe that we started a new one, and it started around 2002 when we started that. It had some preliminary research before that, but the professional part started around 2002. Now, why does it work? And I'm coming now a little bit more into the technical part. Why does it work, and why didn't other systems not work? Well, basically, we had some very known problems like overlearning. That's a very, very strong problem. We solved that. There's no overlearning in our system. There's another problem on resources. You either had enough synapses but not enough cores, and you had to these layers, and then you didn't have a big enough input layer and all that stuff. That's solved. You had an uncontrolled fuzziness because somehow you needed to get in the fuzziness in order to get some results and some weights and some judgments. Now our data space is totally sharp. There is not a single unsharpness, and we know before what happens afterwards. The unsharpness comes by the question. So if you ask unsharp, you get an unsharp answer. If you ask sharp, you get a sharp answer. And that's how we do as humans. If I just tell you yellow, sure. Now, to my opinion, that's wrong. Maybe for you this is right. So if I would say it's yellow, it has a kind of it's a fruit, you can peel it, it's white inside, you can eat it. If I describe it like that, I maybe get banana back. So as more information I get, as more precise the answer comes back. But we have been trained the other way around. If you're working with an SQL database, if you like to have an answer, just key in one word, you get an answer. If you key in 20 words, you don't get an answer anymore because, it's not possible. So we're not used to that anymore. Random results, not discrete. That means our system is absolutely controlled. We know before what happens afterwards, even in the neural layers. We can tell you exactly why, when, where, what happened. I will show you later on. And all these other arguments. So that's all solved. Now that sounds a little bit magic probably, but that's not because we are so clever. That's because we have another concept. Because in the concept that doesn't apply. Now what we have is, we have a very, very simple basic concept. The concept is a cell core and a synapse, and that's it. So we are in the neural field, but it's a very, very simple, because if you look in the nature, also the nature has on one side a big complexity, but the other side it's very simple. Once a cell is destined for a certain function, it just remains in that function. It doesn't have to do other stuff. It's there now, and it's either a muscle or whatever the destination is, it will remain there. So at the end, it's a very simple steady state machine at that position. And that's exactly how we have designed the whole thing. Our cell cores are very, very small agents, steady state machines. We know exactly why and when they behave. And the trick is to have many of them, millions of them, like we have in the brain. And that will create the complexity and the ability to solve complex problems. So the basic construction is very simple. And what we know is, we claim we know why a cell is reacting or not if she's hit with a stimulus. And, it's not more and no less than that. And the problem was, when we found out that, we had a problem, how do we apply it? How do we play that? How do we bring it into a form that we have full control and full access? And that's then how we constructed the neural situation and our neural data space. And we call it data space because it's an n-dimensional data space including time. Because especially on text, on language, you have to have the time inside. Because there are words out there, 20 years ago, they had another meaning than today. And if you don't have this timeline, you don't realize that the meaning of this word is a good word, and then 20 years later it's a bad word. So that's the semiotic part. Now the same happens and applies to data, to pixels, to anything. And so what we know, why those cells react, how they react, we can control them, and we can tell before it happens what will happen. And this is the right part and the right construction how to solve problems like